this first activity. Okay. So the first one is integral 1 over from 0 to 1, 1 over x squared dx. So do you guys know how these work?
Kind of, not really though.
Yeah, I'm in the same boat.
Okay, so I understand these ones better than the type 1.
Yeah.
Okay.
I don't know, like the type 1 was hard. I mean, I got them, but so for these ones, I guess there's like in the denominator there's something within within the range. There's something in a denominator that makes it 0, so there's gonna be like a vertical asymptote.
Okay.
So that's like what you have to find essentially, and sometimes it's on the side, sometimes it's in the middle, sometimes it's on the right side. So like you'll have to look for where it is. So like on the type 1, did you guys get them pretty good?
Not really.
Yeah. I had to keep looking at the answer key to make sure I was doing it right.
Right. I
I'm
mean, I
not
got
confident with it if that's what you're asking.
well, I just wonder about like the concept um, when they are used. I kind of forgot about that, like because I spent more time on type 2. And I mean, I know they were like drifting into like infinity or whatever, or and then you could calculate whatever it was still by the limit, or but I kind of don't really remember.
So to me, it seemed like Type 2 had a vertical asymptote and Type 1 didn't. Is that correct?
Uh-huh. Yeah.
Okay.
Yeah. All right. Well, like if we look at this one, we can see like that 1 over x squared. Like if x is 0, there's clearly the denominator is going to be 0.
Yeah.
Yeah.
So and I guess it kind of did like using a and b and like substitute it. Like so, what I wrote was like limit as a goes to 0 from the right. Um, and then like the integral sign 1, and then put in a instead there.
Uh-huh.
1 over x squared, and then just like integrate, I guess. Um, well, then, yeah, like, so integrate, so you get like negative 1 over x from 1, no, from a to 1.
Yeah.
And then, I mean, it's a definite integral. So you just plug those in, like negative 1 over 1 minus negative 1 over a. And when a is approaching 0, it's never going to get to 0. We get negative 1 minus negative 1 over a. So that's negative, that's like negative 1 plus 1 over
1 over A.
a, which goes to infinity when x is approaching, or when a is approaching 0 from the right. So was that kind of
Yeah, that kind of makes a little bit of sense.
yeah. I mean, I've just done a bunch of them, So like what I've noticed like was that if you take the one on top, you substitute it for, they use b for that one, and the one at the bottom on the integral, like you use a, and then you have to look from which way it comes from, because that's gonna matter if it's from the right or from the left, and you can tell that like between where they are, like between the signs of integral, like the which um, between the numbers of that the integral, that the definite integral wants you to integrate. And since it's going to infinity, it diverges.
Okay. So basically, coming from the left and coming from the right, they get closer and closer and closer, but they'll never touch.
Right. Because if it touches, um, it's undefined.
Okay.
So yeah.
Well, should we try the next one?
Sure.
So we have the integral from 0 to 2 of 1 over the fifth root of x minus 1.
Mm-hmm.
So that's coming from the left, correct?
Well, so like, what is making the denominator 0? Which number?
Um, I guess the top one makes it, no, the bottom, the 0.
Well,
It would have
no,
to
I
be
guess
1, wouldn't it?
right. Mm-hmm.
Okay.
Because the fifth root of 0 is still 0.
Yeah.
Yeah. So since the signs of integration goes from 0 to 2, you're gonna have to go in from both sides since there's a vertical asymptote.
Okay.
Does that make sense?
Mm-hmm.
And well, what do you guys think we should do?
Yeah, I don't know. I have no idea.
So we probably need to change the limit then, right? I mean,
Mhm.
if I'm is it always A, or do you use B, or what's
Yeah, you use
the
A
common
and B.
variables? A. So we
Use both.
do A to 1. Oh, okay.
Yeah, but like
So
in this
maybe
case,
A to 1 positive and okay. Go ahead. Sorry.
you use both
Okay.
because you're coming from both sides.
Okay.
So
So
like
we use like
you
A.
use one, and so the first one, um, I mean, it doesn't matter which one you do first, but you can say limit of A approaches 1, and that's gonna be, let's see,
Should we do A to 1 positive and then B to 1 negative?
yeah, yeah,
Okay.
that's how it is because A, they use what they've done is that they put the B on the top, So, um, so that one goes from 0 to 1, since that's on the top. And then the other one is going to go from 2 to 1. And then you have the A on the bottom.
Okay.
And then you have two integrations. Like, so you have limit as b approaches 1 negative, and then like the integration sign b on top and 0, and then like 1 over x minus 1 to the 1/5 power, plus the limit of a as it approaches 1 from the right, and then 2 integration 2, and then down on it's a, and then 1 over x minus 1 to the 1/5 power. And then you integrate those. And then after you integrate them, you plug in the numbers. Um, and the letters, I suppose.
Hmm.
How's it going?
Slow. You're right. This is a big assignment.
Yeah. Maybe this is the wrong one to do.
Hmm.
It's always hardest. The first problems are always the hardest.
Yeah.
Then
Trying
once
to
you see
understand the
the
concepts.
patterns and so on, then it gets easier. So where are you guys at?
I'm just substituting the numbers back in and the letters. So
Okay. And then when you do that, you can see like as b goes to 1, like what's gonna happen to it. Like, is it gonna go to 0 or like infinity or whatever, or like a certain number? You'll see that.
You pretty close, Matt.
I think I'm done, but I'm not sure.
Yeah, this is definitely
I mean,
tough.
well, not being confident, you always look at your answer like, is that right?
What'd you get?
So I got 0.
Yeah, that's what I got. Is that right? Because I don't feel confident about that.
No, it's correct. It's correct.
Okay.
Yeah, it converges too.
Okay.
So I guess what is the difference between it converges and it diverges?
So when it converges, it goes to a certain number,
Uh-huh.
and when it diverges, it usually goes to negative infinity or infinity.
Okay.
Okay.
That's the application, but I don't really know what it means, to be
Yeah.
completely honest. Um, hmm. Yeah,
Okay. Well, should we do 3 and then we could probably call it?
sure.
Yeah. These
I'm
usually
definitely
take
gonna
me a
go
lot
get some.
longer.
I'm gonna go get some help on this one from the math lab.
Yeah,
What's
I'm in
that?
the same boat.
I'm gonna go to the math lab for this one.
Yeah,
Do you go there very
big.
often, Matt? Matt, do you go there very often?
Yeah, I'm usually, well, except for the last 2 weeks when my kids or wife have been sick, I'm usually there every day.
Oh, really?
Yeah.
I haven't been there at all.
Do you?
Yeah, that's hard.
Well, you know they have online tutors, right?
Yeah, well, if I need help, I can ask my dad. He knows
Oh,
this. And I also have an account on Wolfram Alpha.
yeah, me too.
And if you pay for it, they will give you like the steps how to do it, how to do problems.
Okay.
So rather
Yeah,
than just give you the
for
solution.
for quick for quick help there, if you go into the tutoring, though, they have a live chat with tutors
Yeah,
for online students.
I know, but that one is terrible.
Oh,
I've been a tutor
it's
there.
pretty bad.
Well, it
Oh,
takes a half hour problem for an online tutor to, and usually they don't know calculus, those who sit there.
yeah,
So,
I've noticed that too. And being in the lab, I see which tutors go to help out with calculus, and they're not usually the better ones. But
no. No, I know. You want someone that has quite a bit of experience in it. So,
yeah,
but yeah, let's do number 3.
okay.
Um, so x ln x from 0 to 1.
We'll only have one side on this, correct? Because it's
Yeah.
just from 0 to 1.
Yeah. No, well, it's on the 0, right?
Oh, yeah. Yeah, it's on the 0.
Coming from the right. You substitute the a for the 0. And we have to use the UV integrator.
Fun. That's my least favorite one.
Yeah,
Really?
as well.
Well, like I don't have a problem doing it. It's just seeing that you have to do it. If that makes sense. Like, oh, that's one of those.
Oh, it's one of those. Yeah, okay.
Okay. So, I guess we set u equal to ln x and du equals to 1 over x.
Yeah.
Then dv equals x dx and v is x squared over 2. Where are you guys at?
Writing out this equation that what's
So
that guy's?
I'm putting a dv and the v back in. So
Okay.
I think the scary thing for me is when there's so many steps, because I mean, I maybe it's just the lack of confidence that when I come to an answer, I really question if I did something wrong.
Right. Well, go check your answers. Well, go check it. Like,
Yeah, make sure it's right. I understand. Punch back in.
well, I mean, check your work. Yeah. Well,
Oh,
I
I
mean,
see what you mean.
I think you should always check, like, because
Oh yeah, I do. It's
like
just a
that's how you
matter of
learn.
the
If
word.
you don't know, if you don't know what you're doing right or wrong, you're just gonna keep doing wrong or right. Like, so I think it's
That's
good that
true.
they have the keys there, because you can go and look at first, like, if you're stuck, you can move along and see like what they did, and then like replicate it and so on. So like here, I think I had to use quite a bit of the key, and then I went to the homework in my math lab. I could do it without it.
Yeah.
Yeah.
Okay. Well, according to the key, I got it right. I'm just not sure if
Are
how
you
I did.
done?
Yeah, I got it.
Oh well.
I'll wait
I guess I'm just confused with the
for.
second half when it's the a squared ln of a over 2 minus
Yeah.
a squared over 4.
Yeah. So for the a squared ln a over 2, you have to use like Shatley-Yar's principle and set it like, so you'll have to bring down the power, the a squared. So like that's gonna look like ln a divided by 2 divided by a squared. And then you take the derivative of the top and the bottom, and that's gonna get you to a squared. And then you can see that if you plug in 0, or infinitely close to 0, you're going to get 0.
0.
Yeah.
Okay.
And a squared over 4, if you plug in something really close to 0, that's just going to go to 0.
Yeah. So both of those are 0.
Yeah,
And the first half was negative 1/4.
right. So it converges.
Converges at negative 1/4.
Yep.
Okay, that's what I got too. Okay.
It's starting to make a little bit more sense.
Yeah.
Practicing. It's like every assignment.
Cool. Well,
Cool.
Are you taking that
I'm
quiz
gonna
yet?
live with.
no, I'm
No.
going to right.
Yeah.
This should be fun.
Yeah, hopefully.
Well, I mean, we get to have our notes, or not notes, but like homework notes.
Yeah.
Yeah.
So if you just write out your problems, you should be fine.
That's why I do well
Anyway.
on quizzes and not on tests. All right.
Oh, last
Well-
test, not fun.
Yeah.
I did not like the last
Uh,
test.
Okay. Well,